Hi guys, welcome to this video looking at displacement reactions and redox. Okay, if we start off with what a redox reaction is, you should hopefully remember by now, redox means reduction and oxidation. Reduction is gain of electrons and oxidation is loss of electrons, and you can remember that with the acronym OIL-RIG. If you're not sure on that, I will put a link into the top right hand corner. Make sure you watch that before you continue with this video. So how does redox work in terms of displacement reactions? To do that, let's have a look at a balanced equation. So I'm going to start off with potassium bromide, KBr. I'm going to react it with chlorine, and it's going to make potassium chloride and bromine. This reaction occurs because chlorine is more reactive than bromine, therefore it displaces it. So I've got my balanced equation here. The next thing I need to do is put in my state symbols. AQ, aqueous for KBr, chlorine is a gas, potassium chloride is aqueous, and bromine is a liquid. If we then move on to the Ionic equation, simply all we do here is we take anything that's aqueous and we split it back up into its ions. Potassium is in group 1, so it's going to be K+, and I've got 2 of them. Bromine is in group 7, so it's going to be Br-, and again I've got 2 of them. Chlorine is a gas, therefore I do not touch it, it stays as Cl2. Potassium chloride, potassium splits up into K+ again, 2 of them. Cl-, 2 of them, and then bromine is a liquid, so again I don't touch it. The next thing I do is I take out anything that's the same on both sides, which in this case is potassium, so my 2K are identical and there is nothing else that has changed. I can then rewrite that out, so I end up with 2Br- plus Cl2 goes to 2Cl- plus Br2. Now, as I've said, you've got the OIL-RIG acronym, so oxidation is loss and reduction is gain. So we need to have a look at these and figure out which one is being oxidized and which one is being reduced. So if I start out with bromine, then let's write the half equation because this will help. So I'm going to start off with 2Br- and I'm going to end up with Br2. How do I get from Br- to Br2? Well, bromine, to become an ion, has gained electrons, therefore to get it back to its original molecule, I've got to take electrons away. So I put 2E- on the right hand side. Chlorine is Cl2, and what I'm going to be doing is I'm going to be adding electrons onto both of the chlorine atoms to turn them into ions. So it's going to end up 2Cl-, therefore I'm adding 2 electrons on, and therefore it is gaining electrons. If it's gaining electrons, if we look back at the acronym, it is reduction. And therefore bromine, which has lost electrons, has been oxidized. If we have a look at another example, so 2Kbr plus F2 goes to 2Kf plus Br2. Again, potassium bromide is aqueous, fluorine is a gas, potassium fluoride is aqueous, and bromine is a liquid. So I write my ionic equation, which is 2K plus 2Br- plus F2 goes to 2K plus 2F- plus Br2. I remove anything that's the same on both sides, which again is my potassiums, and that leaves me with 2Br- plus F2 goes to 2F- plus Br2. I can then write my half equations. So if we start off with bromine, that's 2Br- goes to Br2, and how do we get from Br- to Br2? We take 2 electrons away, lost electrons, it's been oxidized. Fluorine has gone from F2 to 2F-, therefore to do that I have to add 2 electrons on, so it's been reduced. Okay, that's everything from this video. Again, if you're not sure on how to write ionic equations, there's a link in the top right hand corner. Click on that, have a watch. So I've got 4 questions for you, all around the displacement reaction between sodium iodide and chlorine. So you've got the equation, 2NaI, which is aqueous, plus Cl2, which is a gas, goes to 2NaCl, aqueous, and iodine, I2, which is a solid. Number 1, describe what will be seen in this reaction. So talk about the colour change, talk about the change in state symbols. Number 2, write the ionic equation for the reaction. So remember, split all the aqueous ones up back into their ions. Again, if you're not sure how to do that, check on the link in the top right hand corner. Number 3, write half equations for chlorine and iodine. So what's going to happen to them in terms of electrons, and then explain where oxidation and reduction has occurred in this reaction. Use those half equations to help you. Pause the video, have a go, we'll see how you've done in a minute. Okay, let's see how you've done then. So if we start off with what would be seen in this reaction. So to begin with, we've got 2NaI, aqueous, going to 2NaCl, and we're doing that by adding chlorine, which is changing and depositing out iodine. So the first thing we're going to see is chlorine, which is a green gas. So we're going to see something go from green to iodine, which is a black or grey. So you get 1 mark for each of those colour changes. The only other thing you could have said is that you have a solid appearing. So there would be a solid formed, which you can see by having a look at the state symbols. Okay, so if we move on to the Ionic Equation then. So if we start off with sodium iodide, sodium's in group 1, so we're going to have Na+, and we have 2 of them because of my balanced equation. Iodine is in group 7, therefore I'm going to have 2I-, and chlorine is a gas, therefore we don't change it, so it stays as Cl2. That then goes over to the same 2Na+, but in this case I've got chlorine as part of my aqueous solution, so I'm going to have 2Cl- and I2. The next thing you want to do is remove the things that are the same on both sides, which is my 2Na+, and therefore your Ionic equation is 2I- plus Cl2 goes to 2Cl- plus I2. You get 1 mark for the left hand side and 1 mark for the right hand side. If we move on to the half equations then. So if we start off with chlorine, chlorine is starting off as Cl2. We know we're going to end up with 2Cl- because it tells us up here. How do we get from here to there? Now remember, if it's got that negative ion, it means we've got a chlorine atom, which normally has 7 electrons in the outer shell, but it's gained 1 to become negatively charged. So to get from there to there, we have to add an electron on, and then you need to balance it because I've got 2 chlorines, therefore I need that. So you get 1 mark for going Cl2 plus 2E- goes to 2Cl-. Iodine is the opposite way around, so we're starting off with 2I-, therefore I'm already in this state where I've got my 7 electrons from iodine and 1 from somewhere else, and I want to get rid of it. Therefore, I'm going to turn back into my I2, remembering halogens are diatomic, and to get rid of my 2 electrons, I put it on the right hand side, so it's 2E-. So you get 1 mark for 2I- goes to I2 plus 2E-. On to question 4 then. So this is bringing everything together and talking about redox. So let's start off with chlorine. It's gained electrons. We saw that because in our half equation it's on the right hand side, as you can see here. And therefore, if it's gained electrons, oil rig reduction is gain. So 1 mark for its gained electrons, 1 mark for reduction. Iodine, from our half equation you can see it's on the right hand side, therefore it's been taken away. So iodine has lost electrons, and then if it's lost electrons, oil rig, it's been oxidized. So you get 1 mark for each of those. That brings this video to an end. There is a review question, which is write half equations for the reaction between magnesium chloride and fluorine. Use it to explain where oxidation and reduction has occurred in the reaction. So it's exactly the same we've just talked about. Remember, it's the aqueous ones that you dissociate, you turn into the ions. The gases you leave alone. Do the Ionic equation first, use that to write the half equations, and use that to tell me which has been oxidized and which has been reduced. Here's a little clue for you. Anything that starts off in the compound, so in this case magnesium chloride, the one that starts off as an ion is always oxidized, loses electrons. The thing that starts off as the element on its own, so Cl2, Br2, F2, is the thing that is reduced and gains electrons. Hi guys, thanks for watching. If you enjoyed the video, please click on like down below. You can have a look at my latest video up there. You can also have a look at my website if you haven't seen it before, and you can click on subscribe down below. Bye now.